Good morning all. I'm going to teach you the introduction of machine learning. First of all, the definition for the machine learning. Machine learning is the process of teaching a computer to recognize patterns in data so it can make predictions or decisions automatically. Say for example, it is going to classify the email is spam or not. How accurately the machine is going to calculate it? With that we can say the efficiency of the machine. So here the task for the mission is to identify the vehicles in the parking. So it need to identify the vehicle is which type, whether it is a bike or car. So now it is going to see the picture. By seeing the picture, it need to predict the vehicle type. So how can we predict the vehicle type? With the features. Okay, so for the car, the features are wheel, height, weight and colors, which is called as a features. So that we can represent it with the help of the sets like this. So F is equal to F1, F2, F3 up to Fk. So this F1, F2 and all representing in the features. Next is weight. How the feature is going to help the machine to find out the task. So which is going to be considered with the help of the weight. Okay, so the feature of the car is for wheel, height, weight and color. But which feature is going to help the machine to identify it correctly is much priority we will be giving to the wheel. So we know already if it is a four wheel, we will be identifying it as a car. If it is a two wheel, we will be identifying it as a bike. So which is much important feature to find out the vehicle type easily and correctly. So weight for the wheel is much compared to all other features. So which is called as a weight. So now we have been represented the features along with the values for all the inputs. Then feature vector, if we are representing the features F1, F2, F3 like that for all the inputs, which is called as a feature vector. So now good feature, bad feature. As I said already, with the help of the weight, we are going to mention the how much the particular feature is important to the machine to find out the task. So here we are saying that as a good feature and bad feature. Say for example, if it is a four features, okay, so as I said already, wheel is the good feature. Even though with the help of wheel, if you can't able to find out the task, next we will be giving the prioritize to the height, because car height will be differ from the bike height. The same way weight is also differs. So these are all called as a good features. But color is not a good feature, because with the help of color we can't able to find whether it is a bike or car. Bike also will be in red color, car is also will be in red color. So with the help of color we can't able to identify, so it is called as a bad feature. Next, first of all we are going to training the machine with the data set with the help of the single feature. So if it is a four wheel, we are going to declare it is a car. If it is a two wheel, we are going to declare it is a bike. Okay, for that only we are going to train the machine. It is also got trained. So whenever you are giving the inputs, whenever it is seeing the four wheel, it will be declaring the output prediction as a car. Two means it will be predicted as a bike. So now the So now after training the machine with this data, now we are going to give the new input or new data to the machine to identify the vehicle type. So we have been given this vehicle to the machine. it has the two wheels, so it is going to find whether it is a which vehicle type. So it found the vehicle type properly because it knows well if the wheel is for car and wheel is to bike. So it is going to predict how many wheels are there. So it knows well if it is a 4, 100% it is car. If it is a 4, 0% it is a bike. If it is a 2 wheels, 100% it will be a bike and 0% it will be a car. So this is the learning it have been got from the training data set. So now it is going to analyze the input image. So it has the two wheels. So now two wheels means the probability it is mentioning that is a bike. So it will be finally giving the predicted output whether it is a bike. So we can make it in the multiple ways with the probability we have been made. With the chart also we can able to make. Okay, now all the inputs we are going to align how many wheels. So here the x-axis is represent the number of wheels, 1 wheel, 2 wheel, 3 wheel, 4 wheel, 5 wheel, like that it is representing. So now according to your input we are arranging, okay, whatever it is bike, okay, that and all 2 wheels, that and all will be placed over here, the cars and all placed will be over here. Okay, with the help of this classification, we can say these are all bikes, these are all car. Through this way also, the input will be placed over here. So it will be bike, like that. It can make a decision. Now, the next input we are going to give as a car which have two wheels. Now, it will get the confusion whether it is a car or not. So, we know already if it is a 4 wheels, 75% it will be a car, 1% it may not be a car, it may be a bike. The same way, if it is a 2 wheel, 75% it will be a bike, then 1% it will be a car. So, out of 4 figures, 3 figures are representing it is a car, so 75%. But one is bike, so the wrong failure is 25%. Like that only for car also. So the input feature is not sufficient to finalize the given images bike or car. So now for this particular figure, 2 wheels, so it is going to declare as a bike, but actually that is a car. So now with one feature we can't able to conclude the output correctly. So we are going to include some more features to identify the vehicle type. So for that we have been taken along with the wheel, we can take the height, because if it is a car, the height will be greater than 5. If it is a bike, the height will be lesser than 5. So the height difference is there. So we are going to take a condition for car greater than 5, for bike lesser than 5. Now we are going to predict if it is have a 4 wheel and height is also high, then 100% car. If it is a 4 wheel, then height is low, then 100% it is a bike. Then 2 wheel and height is also high, then 100% car. Then 2 wheel, low in height, 100% bike. The same way, 4 wheel, low, 0%, because here the inputs are properly we have been given. So now for the new input, 2 is the wheel but height is high. So it will be declaring as a car. Then the other way of representation. So earlier we have been splitted only the wheels, only the one feature we have been taken. So x-axis we have been considered the wheel alone. So now in y-axis we are going to consider the one more feature, that is height is low or high. Okay. So now each vehicle we are going to take. So here if you are looking, so it is a four wheel, then height is also low. So we categorized here. Then here more than three wheel, okay, but height is low, so we have been categorized here. This one two wheel but height is high. Here four wheels, height is high. Okay, so from the picture itself we clearly knows here two wheel low, so this is considered as a bike. But here four wheel but height is low, so again we are going to consider as a bike only. But with one feature we may think this is a car, because we have been trained the machine like that only, so it will be recognize it wrongly. So now for the correct prediction we have been included the one more feature. So with that second feature it will be categorizing the vehicles properly. So the down completely bike, the upper one completely car. So here if you are looking this car, this has a two wheel but it is a car. Okay, now it will be recognized properly. So the summary of the topic. So here we have been identified the complete features of the particular image. From that we have been extracted the features whatever is for the vehicle, because the image is given for the vehicle. So we have been extracted the features like wheel, height, weight and color. From that we have been removed the non-informative features. Out of four features, the wheel, height, weight are good features. So we have been considered that as an important feature. The color is not much important. So we are considering that as a non-informative feature. Then we have been built the classification model from the data. Initially we have been classified with only one feature. So that works well for only the few images whichever is given properly the wheel. But some types of models are differs from the basic one. So the three wheel bike or two wheel car is also possible in the reality. So that time the machine won't make a classification properly. So to avoid that one, we have been given more features to the machine to train about the vehicle type. So we have been added the height is also one more feature for the prediction. Now the machine will be training the model with the help of wheel and also the height. Initially it will be checking the wheel. If it's satisfied, okay, next it will be checking the height also. Okay, if both conditions are satisfied, it will be declaring as a vehicle type. Otherwise the wheel will be fails but height will be making as a pass. So the vehicle will be identified according to that. So the performance of the classification task will be done at the end of this concept. Example, as we have been seen in the earlier, if it is a four wheel and height is also high, it is declaring very clear that is the car. But some cars are available with the two wheels also. So while checking two wheels, it can't able to predict properly. Next feature, it is going to check the height. Now the height is high. Due to the height feature, it is going to be finalized that is a car. So the final prediction is correct. The same way bike, while seeing some bike pictures two wheels, it is correctly predicting that is a bike. That is not a issue. But some bikes are there with three wheels. Above two wheels, it will be considering as a car. from the learning of the mission. So the prediction goes wrong. Now